Okay, this short video is show you how to find out the oxidation state or oxidation number for an element in the formula, such as in a compound. So there's some rules regarding the how do we assign the oxidation states. So first of all, in the elements, that should be 0. And monatomic ions, the ON should equals charge. The sum of ON should equals the charge of the species. So for example, if the species is a neutral molecule, the sum of ON number should equal 0. If we're dealing with the polyatomic ion, then the sum of ON should equal the charge of the polyatomic ion. And for the ionic compound, we should really work on each ion, especially polyatomic ion, separately. And then once getting to the specific rules, B sets of rules. So when we apply those rules, we should keep in mind when we look at the formula and decide which elements should decide the oxidation number, the OM, first. We follow this order. Okay, so the first one in a compound, if the group 1A, 2A, and the aluminum, zinc, silver, those ions, and their charge is fixed. So we should know what the charge, the ON should equal charge. So this is dealing with when the such elements are in a compound. Okay, and then the next level for the for fluorine in a compound, because fluorine has highest electron activity, the fluorine always tend to gain electrons, so we assign the ON number equals -1 in all the compounds. Remember, this does not include in the elements such as F2 element. For hydrogen, normally we assign the +1 due to its lower electron activity than most nonmetals. But when the hydrogen form compound with such as in the metal hydride, the hydrogen should be -1 as a charge, as oxidation number, and as well as a charge. So once we have the B1, 2, 3, the orders B1, B2 has the highest priority. And then the other elements follow the order as they show up in the table. Okay. The next is dealing with oxygen. Oxygen, normally it is -2 because the high electron activity, except when the oxygen form bond with the fluorine or in the peroxide compounds, such as when the two oxygen form bond have a single bond in between them. And then the next group 7A, the halogens, oxygen number typically is -1, but there are many exceptions because such as when they form the AT ions, such as chlorate, the oxygen will assume the -2 oxygen number, which will make the halogen some positive number. We'll see some example in the following. So this is general rule, and when we work on the next slide, we'll refer to this slide very often. So make sure, feel free to flip back to the PowerPoint, this page, to check the rules, especially pay attention to the order, the sequence, how we use those rules. So this slide shows you some examples. I'm going to walk through each one formula one by one. The first, zinc chloride. Okay, zinc chloride. So in the zinc chloride compound, the zinc should have a +2 charge, and we should have this formula. And according to the rule in the previous slide, zinc should have a +2 charge, chloride -1 charge. So obviously our number for the zinc should equals +2, chlorine should equals -1. Next, sulfur trioxide. Sulfur trioxide. So if we go back to the previous slide and find out which element we assign the oxidation state first, we realize first of all, this is a neutral molecule, so the sum of the ON number should equals 0. So that means I can write down the ON number for sulfur plus 3 of the oxygens. And oxygens, as we see from the previous slide, it has -2 oxygen number. and the sum of the ion number should equal 0. By solving this equation, we solved S equals positive 6, which is the oxidation state for sulfur in this compound. Next, nitric acid. And nitric acid is actually an ionic compound, has the H+ ion and nitrate ion. So we have a hydrogen SN number, the ON number will be equals to positive 1. We put the ON number right above the symbol of the element. And now I work on the nitrate ion. The nitrate ion, as a polyatomic ion, the sum of ON number should equals -1, the charge of the ion. So I write down the equation: nitrogen plus 3 oxygens. And again, we see oxygen in the formula should assume the -2 ON number. And the sum of these ON numbers should equals charge of this nitrate ion. Nitrate ion -1 charge. So by solving this equation, we find that nitrogen equals +5. Next, we have, this is a formula for glucose and a series of some other simple sugars. And so this is neutral molecule. And then we have 6 carbon. We can write down the formula. The sum of oxygen number should equals 0. So 6 times carbon plus 12 of the hydrogens plus 6 oxygen atoms should equal 0. And then refer to back to the previous slide. We notice we assign the hydrogen first, which is +1 in most compounds. And here there's no alkaline metals involved, so there's no need to worry about the other oxygen numbers for hydrogen. The hydrogen in the formula should have +1 ON number. Okay, next, in the previous slide, the rule says oxygen should be -2. So put it down. That add up should equal 0. So the next, by solving this equation, we get 6C plus 0 equals 0. So therefore, the carbon each have 0 oxidation number in this formula. So even though the carbon has 0 oxidation number, does not mean it is in the element. It is just a special scenario of compound where the carbon happens to have a 0 oxidation number. Next, sodium hydride. Okay, sodium hydride. This is an ionic compound between sodium metal and the hydrogen as a nonmetal. Because nature of the bonding, the metal should lose electrons. So the sodium should have a +1 charge, which is the same as oxidation number. And the hydrogen should equals, because sodium as an alkali metal always have a +1 ON number in the compound. And the sum of ON number should equal 0, and therefore the hydrogen should equal -1. So you can see hydrogen might have some variations in ON number. And in the compound, the last formula, this is the we call the persulfate. Okay, this is actually the persulfate ion. And so we follow the rule according to a previous slide. The sum of the ON numbers should equals 2 minus. And then we have 2 sulfur and 8 oxygens. Add together should equal the charge, which is -2. And then based on the previous slide, the oxygen in a compound should be -2 unless it is in a peroxide bond. Here, the oxygen, it is -2. So combine together equal -2. And by solving this equation, we have a 2s minus 16 equals -2. Finally, solve S equals +7. Okay, so this is how we find out oxygen numbers in each of the elements.